incredible change, what happens is actually the most adaptive will thrive. The most adaptive organizations, adaptability has become a core competency. But it's not something that, is alive and well in the world of work. So a lot of my work involves taking something as sort of left field and, soft as creativity and bringing something solid to it so organizations can digest. And we have very, very, very small capacity for solving problems in a linear way. In fact, if you think of your conscious processes, or your conscious resources, as being about a cubic meter in space in terms of how much you hold, then your non-conscious resources that you can't directly access, those are about the size of the Milky Way by comparison. There's an extraordinary difference. And it turns out that most of the problems we solve at work are basically too big for conscious resources. They're like, multiplying to, two sets of big digits. Most of the problems at work are not adding up 2 and 2. They're very complex. And so we really need to access the kind of the Milky Way, not just the, not just this cubic meter. But we're not very good at that. In many ways, conscious thought, like doing math or trying to solve a problem, that actually stops the insight coming through because it's noisy. That's a really helpful thing to understand. And by the way, anxiety, like, oh my gosh, where's my watch? I've lost it. Any kind of anxiety is very noisy electrically. Even a tiny bit of anxiety, like just, oh, someone's watching me, or, oh my gosh, I've got a deadline. Even a really small bit of anxiety has a very big and unexpectedly big impact on being able to notice quiet signals. Okay, so quiet is one quality. There's another one, very important, internally focused. Now, we know what this means in the lab, very specifically. We know that you're activating your medial prefrontal cortex, which means you're actually thinking about yourself. You're looking into your own thoughts. Jonathan Scaller calls this mind wandering. It's very relaxed. It's what you do when you're not putting the effort in. It's what you do when you're like, it's kind of like the gossip magazine of the brain. It's sort of what you do when you really don't want to think at all. You're just sort of thinking about yourself and thinking about things. Okay? So you've got to actually be looking into your thinking in order to have insights. And one of the reasons we think that is that the signals are quiet. And here's what happens. When you look into yourself, you actually shut down the visual and auditory cortex. And you quieten the noise overall. You actually see an alpha effect. You see, and this is the alpha effect up here, you actually see an alpha of the visual cortex and the prefrontal, which basically in English, you're not listening or seeing. And you're able to, again, notice those subtle signals if you're looking inside. So if you're trying to have an insight and you're focusing hard on a problem, you don't have the insight. You've got to actually go a little bit internal. Now, that's the bad news. Good news is the average is about 2 seconds that you need to do this for. So you need, on average, about 2 seconds of quiet in order to actually have this insight. Now, the third quality is probably spoken about a lot here, and I think in the program I've seen this come up a lot. You have to be slightly positive. Now, the bad news, though, you don't want to be too positive. You don't want to be overexcited. You don't have insights when you're really happy. You have them when you're just a little bit happy and kind of curious and open. And again, it comes back to noise. If you're really happy, there's a lot of activity, a lot of buzzing, right? A little bit happy, there's a lot less noise. Now, here's the reason. Well, firstly, I'll show you the evidence. Don't worry about all the technical stuff. Basically, as you get happier, people have more and more insights. But it doesn't affect linear problem solving much. So as you get happier, you have more insights. As you get more anxious, you have less insights. Again, no significant pattern on linear problem solving. And this has been repeated in many labs over and over. Very big difference between slightly happy and slightly unhappy. Very, very big difference. And one profound study, which really just threw me for six, this is an amazing study that brings this to life. 2 groups of people, there's hundreds of people in each group, complete a maze. One group completes the left maze, and the mouse and a piece of cheese. The other group completes this, and there's a mouse and an owl. Okay, this is just a cartoon. It shouldn't have any effect on anything, should it? Well, the instruction is just fill in a maze. The maze is exactly the same except for that. The difference in creativity, it was actually a study on creativity, the difference in creativity between the 2 groups was about 50%. 50%. So tiny threats that you don't even know you're feeling turn out to have a really big impact on people. And this is something that we know we've not understood. I have a lot of fun in workshops. I'll give people an insight puzzle, and give a whole room an insight puzzle. And there'll usually be 1 or 2 people who get the puzzles over and over. And all I have to do is just look at them as we do sort of a few more puzzles, and it immediately stops them getting the puzzles, the next ones. I mean, like 9 out of 10 times that's worked every time. Just that tiny bit of pressure stops them being able to solve it. That's all it takes. Imagine what brainstorming does. You know, brainstorming is a huge amount of pressure, tremendously ineffective in its classical form for solving problems because of the noise. So small threats turn out to have a really big impact. In fact, if you're holding a warm glass, you'll have a lot more insights than if you're holding a cold glass. You know, these kind of things are really amazingly big. Anyway, the final thing, and this is a bit of a challenging confound, this is something most of you I'm sure have noticed, is that you actually have insights when you're not actively trying to solve the problem. Okay, you've got to not be solving it. You know, I was talking with Michael before, I was trying to remember the name of a person that we both knew, couldn't remember it, and I just let it go, and 5 minutes later, for me they always come in the restroom, that's what I've got. About 5 minutes later, suddenly the answer comes to me. There it is. So you have to actually not be working on it, right? Partly that's because working on it, if you're not getting it, you get nervous. But there's another reason. There's this inhibition of the wrong answer that's required. And this has been studied by another scientist in Chicago, Stellan Olson. You actually need to stop and dampen down the wrong answer from being active or primed in your brain. When the wrong answer is primed in your brain, the right answer basically doesn't come through. And Taboni's got wonderful techniques for this that kind of shift your attention and, you know, really good tricks for sort of stopping you think the wrong way. But essentially what it looks like is you know, the traffic's kind of going the wrong way and you can't change the traffic until you stop the traffic. You've got to change it, then the neuronal traffic can actually change. So I'll give you a quick example of this. Time flies like an arrow. How do you interpret those 5 words? Just think, you know, how you might interpret that. Time flies like an arrow. You might say, well, time, you know, can't go backwards. Time is sharp. Time can kill you. You know, when I ask this of people, with one company an exception, I'll come to that. With one exception, thousands of people give me the same answer to this, which is a version of this same solution. But to just think differently about 5 words takes stopping thinking about it this way. So for you to be able to see this as check the speed of flies the way you would time an arrow, for you to be able to see it that way, you've got to stop seeing it that way. Because while that's there, you can't see that. And some of you still can't see that, right? Some of you have seen it. So check the speed of insects, you know, the way you would time an arrow. So you've got to like stop the other one. And this is what happens until we stop, you know, one way of thinking, other ways actually can't come through. Check the speed of flies, they're similar to an arrow. Check the speed of flies the way an arrow would. My favourite, time flies, a type of fly, are fond of arrows. Very simple, and it's just 5 words. But what's amazing is, I've shown this to thousands of people. There's only one company where a lot of people got it, and that turned out to be Google. It was actually filmed. You can see my surprise. There's a video of me presenting at Google on YouTube, Google Tech Talk, and you can see all the Google people getting this. And I was like, wow, this is really scary. I need a harder puzzle for these guys. But the point of this is we have to stop thinking one way in order for new ideas to come through. So here are the 4 qualities of reflection. Quiet, internally focused, positive, and not actually actively trying to solve the problem. Now, these are tested in the lab, these are backed by papers, there's a whole journal on this, the Neuroleadership journal, where you can see this kind of work published, and published in the mainstream journals as well. So you can actually start to build a real evidence-based approach for having more insights. The trouble is, this approach is almost the opposite of what everyone does in business. Particularly management, you know, when they try to help people solve problems, management do the opposite of these things. They put pressure on, you know, they create noise, they do all these things. In my own work, without wanting to sound like an ad, but we can get about 500%, between 300 and 500% improvement in people's ability to solve complex problems in short conversations by teaching them about insight. 300 to 500% improvement in complex problem solving, which is pretty useful. Anyway, the final couple of pieces of this, just the final 2 phases. Insight is very, very interesting. The moment of insight is very interesting. It's interesting because it actually changes all the circuitry in a flash, in a way that will never go back. And that doesn't happen in linear problem solving. So linear problem solving doesn't kind of stick in your brain. Insight problem solving sticks in your brain. And by the way, that has some unintended consequences. Like if you solve a problem with insight but it's wrong, that solution will stick with you and you'll get stuck on it even though it's wrong. But we know that having an insight changes the brain. We also know it packs a lot of positive energy. It's a very, very important thing. It packs this release of dopamine, adrenaline, and it pushes back against the kind of homeostasis that exists in all this. So from my interpretation, insight's actually at the heart of change. It's at the heart of learning, but it's also at the heart of change. And without insight, what you get, particularly in the work context, is you get sort of a lot of problem focus, but you don't get real change happening. The final thing is the action part of this, awareness, reflection, insight, action. Insight brings this urgency for action. Action increases the attention to the insight, which deepens the connection. So insight is like the start of a new circuit. It's the potential of a new highway in the brain. Okay, and it can stick with you if you take action, if you do something with it, as you've seen. So there's the model: awareness, reflection, insight, action. You can see there's a lot in the reflection part. If you want to know more about the reflection, I just wrote about this week in Psychology Today. If you look up my name in psychologytoday.com, you'll see a whole lot more writing on this and similar things. I think that's about it. I just want to finish with one comment. Theodore Zeldin, a philosopher at Oxford, he said, when will we make the same breakthroughs in the way we relate to each other as we've made in technology? Extraordinary technology breakthroughs, but very little in how we relate to each other. And the exciting thing about the neuroscience we're seeing is some science-based, evidence-based, hard science for how to improve how we work with each other and also how we work with ourselves, which turns out to be very similar. Thank you very much.